So it has done the job for us. It has already accepted the instruction. Alternatively, we could have used the median of a column or as a substitute. A median is a value located at middle position in the data rather than the arithmetic mean. The instruction is identical to the above with dot mean replaced by dot median. There is also a third option of dropping a row if there are too many NNs. Let's say we have a row where more than 50% of the values are missing. So in that case, it makes no sense to reset so many values that are means or medians. In such case, it may be a preferred option to drop the rows with too many NNs altogether if such rows are few in numbers. I am providing these useful instructions under the notes for a handy reference, so you can use it wherever you want. So right now we are good. So we are next instruction dfcars.loc13. Again our earlier instruction where we checked the content of row 13. df underscore cars dot loc 13. Shift enter. So what do we see here? In horsepower, in row 13, now we have replaced NaN also by the mean of the entire horsepower's column. Now we have cleaned the data, so we can move on to the next part of pre-processing, which is getting all the data in the right format, checking and correcting the data format. .dtypes and .stypes method. Pandas .dtypes method allows us to check the data type of a column. So let's run the instruction. What is the instruction? So simply df underscore cars dot d types, shift enter. Okay, so what do we see here? We find that the data contains horsepower as integers, but it is set up as float in the data frame. We need to take a call based on analysis of the content. Let us say we want horsepower to appear as integer or vice versa. Maybe we want the integers to be converted to float. Pandas provides a method .astypes that lets us change the data type of a variable. So let's modify and then recheck the data types. So how do we do that? So let's do the next instruction now. df underscore cars square bracket horsepower equal to df underscore cars square bracket horsepower dot hash type round bracket or parenthesis int 64, and we change the format and then we check again df underscore cars dot d types. This is the same as our earlier instruction. Shift enter. So now we see, what do we see? We see that horsepower is converted to int like we wanted. So what all have we done so far? We have completely cleansed the data. We have corrected the data format. In short, we are done with the pre-processing and are ready to explore the data. That is to do data visualization. Now moving over to exploring the data. Some instruction for overall view of the dataset. .shape method. This is the instruction to check the size of the dataset. Let's run the instruction. df cars.shape df underscore cars dot shape shift enter. We see that our data frame df cars has 394 rows and 9 columns. Length data frame method. To know only number of rows. Earlier we saw rows and columns both, but let's say we want to know only the number of rows. Then we use length data frame. So how does the instruction go? Let's see this here. Len parenthesis df underscore cars shift enter. So it answers 394. There is one more important instruction, dot describe. to get the statistical summary of all columns like count, minimum, maximum, quartiles, etc., we have dot describe method. So let's type the instruction df cars dot describe df underscore cars dot describe open close parenthesis shift enter. Right. The response is showing us a quick statistical overview of each numerical column in the dataset. Remember that it talks only of numerical columns and not the categorical ones. Number 1, count tells us the number of rows. Mean tells us the arithmetic average, while the median tells the middle value. Median and quartile values tell us how the values are distributed. Min and max tell us the range of the values within the data. The information will be clearer when we see box plot of these fields. So that we'll see as we go forward. So now that we have an overall view of the data, we shall study the pattern in detail. This is done by various types of visualizations. First, we shall look at the numbers, that is numerical analysis, followed by the look and feel of the data. So let's see how we do that. Non-graphical univariate analysis. Univariate analysis is analysis of one feature at a time. Non-graphical means it contains only summaries in numbers, that is no charts. It helps us as a quick check in understanding the distribution pattern within a single column. It also allows us to divide the data into logical groups on the basis of some column, say as in our example the number of cylinders. Now let's see dot unique method. Method dot unique returns a list of unique values. Let's see how we can use it. df underscore cars open bracket single quotes origin bracket close dot unique open close parenthesis shift enter. The response shows a complete list of countries whose car models are included in the dataset. Now, value counts method. Method value count gives us complete details of each unique value within a column with its respective count. So let's run the instruction and study the response. So how does it go? df underscore cars open bracket, let's say cylinders, single quotes, cylinders, get across the bracket, value underscore counts, open close parenthesis, shift enter. The response tells us that maximum models present in the data have 4 cylinders 201, followed by 8 cylinders 103 and 6 cylinders 83. 3 and 5 cylinders models are insignificant and can be ignored from analysis. Using this information, we can filter and subdivide data into logical groups of interest. Let us see how we can do this. Let us say we want to study the behavior of one or two specific items that are most frequent to represent the data. For example, we can select all cars with 4 cylinders, or maybe all models that were created in USA. Below instruction uses a filter to segregate all 4-cylinder car models in the data. So let's run it and view the response. So let's type the instruction now. df underscore 4cell. So this is the name of new data frame we are creating because we don't want to disturb df cars. df underscore 4cyl equal to df underscore cars open bracket parenthesis df underscore cars open bracket single quotes cylinders equal to 4. So we are asking pandas to pick only all those car models who have 4 cylinders and not 6 or 8 of this earlier df cars data frame and segregate them, put them together in a data frame and name that is df underscore forcil. Now, just to check what we're going to create, we also do a follow-up instruction df underscore for cyl dot describe open close parenthesis, shift enter. So see that we have created a separate data frame by the name df underscore forcil that has got number of cylinders only as 4 and all the rows are segregated like we wanted to do. So we have done this part now. As you can see, 4-cylinder car models across all countries from a homogeneous group, as it was created with a common intent of high fuel efficiency. Summing up, we have separated 4-cylinder car data and created a separate data frame by the name df4sil. We shall use this in the part 2 of this project execution, as we'll see later. Now, graphical univariate analysis. So far what we are looking at was non-graphical analysis. That was only numeric summaries. After non-graphical analysis, let us now study the visual side of univariate analysis called graphical analysis. This gives us a more detailed information and it's easier to visualize. So first one comes is the histograms. Histogram is the most commonly used graph to represent numeric data. Histogram provides a graph of some feature like say MPG shown below, plotted against its frequency of occurrence in the data. In histogram, we divide the total range of MPG column values into number of bins of equal size and study the frequency in each bin. So let us run the below entry to generate a histogram for MPG, that is miles per gallon, as it is our target value of this project, right? So using matplotlib library. So how do we do this? Let's try this instruction. df underscore cars open bracket MPG get across go next position dot hist is histogram round bracket bins equal to 12. So this number can be anything. So we are telling pandas that you divide the entire data into 12 such bins and create a histogram of MPG values of df cars. So shift enter. So see that it has generated a histogram here for us. The second type of histogram shown below is an alternative to the one above. It is generated using Seaborn package and it's a bit more sophisticated and gives more statistical detail. So this is only standard syntax, so we will not waste a lot of time in typing each instruction. I will simply copy it from here and run it. So let's do it here. So plot.figure fixed size. We are telling 8,5. This is the figure size. Tight layout. This is the type of layout we are looking at. This is the standard syntax. sns.displot df cars mpg. So we are asking it to create such a histogram using Seaborn package. Shift enter. So look at this. Alongside the histogram, it is also given a curve which clearly shows how the statistical distribution looks like. We can derive following information from histograms. How the data is distributed. For example, whether it is normally distributed or skewed. Normally distributed data speeds up the machine learning process and can get better accuracy. We can also get an indication of outliers, that is values isolated from majority trend. The above diagrams show this data is skewed to the right hand. We see the long tail that is appearing that we indicate as the skewed right. So this you will see maximum number of columns on the right hand side. So it is the right skewed. This skewed distribution could be due to mix of 6 and 8 cylinder engines, which show a distinctly different behavior than the majority 4-cylinder engines. That is, the higher frequencies are more concentrated towards the lower displacement. This is because lower displacement indicates 4-cylinder engines In other words, data shows that 4-cylinder engines are more common than the other types. In case of skewed data, as we will see, sometimes can group data differently for better uniformity. So the next one coming up is the box plots. So what are box plots? A box plot is the visual representation of statistical summary of given data set. The summary includes minimum value, the first quartile, that is the point below which 25% of data lies, median, that is the second quartile, 50% of data lies below the median, third quartile, 75% data below the third quartile, maximum, then the outliers in the data set. So let us run the below entry to generate a box plot of horsepower. So let's type the instruction df underscore cars dot box plot around brackets column equal to horse power. Shift enter. So what does it tell us? The above graph clearly shows the collection of points above the maximum value, which are the outliers. So in this figure you can clearly see that all these points here on top, which are, this is the maximum, this is the upper quartile, this is the median, this is the lower quartile, and this is the minimum value. So all these points are outliers. Below entry generates a more classified information of horsepower distribution grouped by cylinders. We can also break this down by the different types of cylinders. So that will give us the clearer distribution how each of the group by cylinders is distributed. So let us run the entry to generate it. So how do we do that? df underscore cars dot box plot parenthesis column equal to horsepower. Close single quote by equal to single quotes cylinders, cy cylinders. So let's try this out. Shift enter. Okay. So this has generated us like we wanted the classified by cylinders. The multiple is below is another alternative box plot representation by Seaborn.